Currently, we have an index action on the home controller that's only going to use a single thread to do all of the processing inside of this method. That means that the thread spends most of its time blocked waiting for the news client to return the current headline, waiting for the weather client to return the current temperature, because those are very slow web service calls. What I'd like to do is free that thread up and allow for more efficient scheduling of threads so that I can keep a scalable application running. This is not such a big deal for small applications or company internal applications, but if I'm trying to build a scalable website, this is a concern. And in MVC3, I'd have to derive from that async controller base class and write all that code we saw before. Now it's much easier in MVC4. I just need to make this an async action. There's no need to derive from async controller anymore. Just use the async operator on my method, and that means I need to return a task or a task of T. In this case, I'll return a task of action result. So I'm literally giving the MVC runtime back an object that represents the work that needs to be performed to produce an action result. And that's going to allow it to schedule threads a little more efficiently. Now, once I have introduced the async keyword on the method and made it an async method, I need to use await somewhere. In fact, the C# compiler is going to give me a warning right now, not an error, just a warning that says you have an async method that's not using await inside. And that's completely ineffective. There's no point in using that async keyword if you don't have an await inside, because it's the await that allows execution to be suspended and allows a thread to jump out and do something else. So I need to use await, and what I want to await is I want to await getting the headline. I want to await getting the current temperature. Those are the points at where I want the thread to be able to jump out instead of just sitting there and being blocked. And what I need to await is something that returns a task. So right now, get headline returns a string. That's not something I can await. I need to await a task of string. Well, fortunately, when I generate these client proxies for these WCF services, I can get an async version of every method. So if there's a web service method called foo, then I can generate a foo async method. That's all done when you add a service reference to a project. So in this solution, I have the news and weather project. That's where you will find the web services, the weather service and the news service. The MVC application is called async await. At some point, I had to go in here and say, add a service reference to those web services in a different project. And when I do that, or when I configure one of these service references, which I can do by right-clicking on this and saying configure service reference, I just need to make sure that the option is checked to allow generation of async operations and that it is selected to generate task-based operations. That will give me the async versions of every web method that return a task and allow me to use the wait keyword. So what about other pieces of the .NET framework? Well, you'll find a lot of classes in .NET 4.5 that introduce async versions of their methods. So anything that has to do with long-running I/O will probably have a method on that class that ends with the word async. For example, web client. It's something that you can use to instantiate and say download data. Well, now there will also be a download data async that you can await. And you can use this in MVC applications, console applications, Silverlight, WPF, everywhere. So now we have a truly asynchronous method. We have the async keyword in place. We have our await keywords in place. I'm just going to do a build, and then we're going to come back to the browser and refresh it to see what sort of threads we used and what sort of response time we have. And here's the result. So now we can see that we started the action on thread 92, and then we finished it on a different thread, thread 104. And there's always the chance that even though this has async and await inside of it, that we'll use the same thread to start and finish this action. That's just how the thread scheduler happened to turn out. Well, in this case, fortunately, we have two different threads, so you can see that now we're using two different threads. Notice the elapsed time to render is still 4 seconds. That's because we're not doing things in parallel just yet, but at least we're freeing a thread up so it can stay busy. So literally what's happening now is the MVC runtime calls into the index action. That thread comes through until it gets to this get headline async, and at that point, since it's awaiting it, we can suspend execution at that point. The thread can jump out of this method, continue processing perhaps some other requests, and then when that result's ready, the original thread or perhaps some other thread that is used to process HTTP requests can jump back into this code, then wait for the current temperature, at which point it could jump out and do some other work. At some point that result's going to be ready, and we can come in, put the finishing touches on our model, and render the view. I've changed the index action around a little bit so we can get a better understanding of how async and await are working inside of this controller action. What I've done is I've created wrapper methods called getHeadlineAsync and getCurrentTemperatureAsync that are async method themselves, and they're going to be responsible for instantiating the weather service and awaiting the result of the call to get the current temperature. Now this is not typically something that I'd want to do. Specifically, I wouldn't want to create async methods where I'm passing my model around. I would rather have these methods return a task of int or a task of double, grab that result back in the primary action and assign it to the model myself. I don't like having that side effect inside of these methods, but this is just for demonstration purposes, and it makes it easier for us to log when these particular methods are starting and when they're finishing and what thread they're on. So currently this is how the application is structured, and I have it built. Let's just go in and run it in a browser, and the results might be surprising unless you picked up on a subtle bug that's here. So when the results display, we do not have a news headline, we do not have a current temperature, and it only took 27 milliseconds to render, and there was only a single thread that was seen in the index action, getting the headline, getting the weather, and finishing the thread. So what happened here? Well, the MVC runtime knew it had to run the index action, so it picked up a thread and told it to invoke this method. It came in and it started to get the headline asynchronously. And when it hit this line, it said, oh, I need to wait for this task to complete. So I'm going to suspend execution at this point in time, and I'm going to jump back up in my call stack and go to the next line of code, which is get current temperature async. So it comes into this method, instantiates a service client. It finds it has to await another task result. So it suspends execution of this method, and it is still free now, so it can jump back up here, add this finished action, and then return a view. So at that point, even though we had two methods suspended out here, as far as the MVC runtime was concerned, we produced an action result. So it took that action result and rendered a view, but of course the model wasn't completely built yet. The problem was that we never waited for these other asynchronous operations to complete, and that's why we again have a C# compiler warning that you have an async method without an await operator. So if I just put await here, then what we'll be doing is, as soon as we call that method, we're going to wait for the result. We're going to wait for the task that's inside of here to complete. So now if I do a build, then as soon as that completes, I should be able to refresh the browser, and we should see some different results this time, and we should actually get some results in our view. And here's the final results. So we now have a news headline, we now have the current temperature because we waited for those results to get set in the model. And we can also see that we started a lot of these actions on thread 119, and we finished on 120. That's just the way it turned out with the thread scheduler. And what happened behind the scenes this time is that when the thread came into the index action and it called in to get headline async, it also suspended execution at that point and waited for that result. The thread itself might have jumped back into the MVC runtime to do different work, but at some point it picked up where it left off after waiting for those results to be computed. So the other thing to notice about this, we're still doing these operations in serial, so the elapsed time to render was still over 4,000 milliseconds, and that's because we're waiting for the headline call to complete before we go and try to get the current temperature. There's a different way we could do this if we wanted things to operate in parallel, and that is, I don't want to await as soon as I call get headline async. Instead, I could say that we could store this into the headline task variable, and that gives me a reference to the task that gets built by get headline async. And instead of awaiting get current temperature, I'll also assign that into a task variable. And now what I could do is I could say await headline task and await temperature task, or I could also combine those together by saying await task.whenAll. So in other words, when all of these complete. And inside of here, I can list multiple tasks. So I could say, please wait on the headline task, and please wait on the temperature task. And what task.whenAll essentially does is it returns another task that represents the combined efforts of all that outstanding work. So we're going to await for both of them together. But the important part here is that I'm kicking off get headline async, and I'm kicking off get current temperature async, and I'm not waiting until both of those tasks have started running. So now when I do a build and I refresh the browser, we should see the time to render reduce considerably. So let me open up the browser. We'll do a refresh. And you can see we still produce the same results. Notice the elapsed time to render has dropped down to just over 2 seconds, or 2100 milliseconds. And we have a number of different threads executing inside of all these different operations. So this is putting things in parallel. I don't want to await anything until after I've kicked off all those asynchronous tasks. They can happen on background threads. I'll await all the results and put the model together. So async await doesn't necessarily mean that you'll be running on a background thread. Doesn't necessarily mean that you'll be running a bunch of different things in parallel. It all depends on how you structure your code and where you put the await keyword. Since async operations like web service calls sometimes travel to slow and unreliable destinations, it can be useful to specify a timeout for async operations. ASP.NET already has a request timeout threshold, but you can be a bit more aggressive or different with these async methods by specifying a timeout value using an attribute. So the name of the attribute is async timeout, and you specify the timeout period in milliseconds. Let's go with 1200 milliseconds to force this to timeout, because we know those web service calls will require at least 2000 milliseconds. Now once you have the attribute in place, you also need to take as a parameter to your async action a cancellation token, and I'll call it CTK. A cancellation token is something that normally you could pass around to other async methods. What the other async operations can do is check that token to see if someone has requested a cancellation. For instance, I can check cancellation token.can be canceled, is cancellation requested, automatically throw an operation canceled exception if the cancellation was requested. And typically what you would do is you would take that token and you would pass it into the async methods that you're calling. So in this case, ultimately I'd want to pass it into the weather client get current temperature async, except the WCF proxies do not generate a method signature that takes a cancellation token, so there's really nothing I can do with it here. But there are a lot of .NET APIs where the async methods do take a cancellation token, then you can pass it in. Ostensibly, they should be checking that cancellation token and aborting any work in a friendly way in case cancellation was requested, and it'll clean up all the resources and be a little more efficient. But just with the async timeout in place and the cancellation token in place, let me do a quick build and come out into the browser. And what should happen now when I refresh this is that we should get an error because the operation is taking too long. And there we can see we get a system.timeout exception. Now I can customize that error message if I want, and this all goes back to error handling in ASP.NET MVC. We know there's a handle error attribute, and that handle error attribute will jump into play if custom errors are on. So off is great for debugging because you get to see stack traces, but on is what you want to use for production, or at least remote only, so that your customers see pretty error pages. And let's say that I want a specific error view dedicated to this timeout scenario. So I have a timeout.cshtml view that's here in the shared folder, and I want to render that when there's a system timeout exception. The way I can do that is add an additional handle error attribute here. And I could say that when the exception type equals type of, and the exception that we saw back there, which was a timeout exception, which is in the system namespace, so we'll bring that in. So when the exception is that type, then the view to render is going to be the timeout view. And now let me do another build. And we'll come back and refresh the browser. And this is what our users should see when this operation is taking too long. They should see this custom error view. What happens if something goes wrong in an async action? In other words, what happens if we get an exception? Well, I've already shown you one example of what happens when we get a timeout exception and how we can go to a specific view using a handle error attribute. But what about other types of exceptions? Exceptions that might be thrown by WCF, or exceptions that are just generally thrown by an async method that we call into. So the scenario now is we're going to call getCurrentTemperature async. It is ultimately going to throw an exception. And we'll call getHeadline async, and it's ultimately going to throw an exception. And I'll point out that the first call we make is to getHeadline async. So that would be the first call that we make here. And so with that in place, let's see how the application behaves. I'm going to change the timeout so that we don't get a timeout error here. And I'm also going to go back into web config and turn off custom errors so we can see the exception that gets thrown and see a stack trace. And once that's built, let me come out and refresh the browser. And what we'll see is the system.exception no news that was thrown by our async news method. So if you expected to see an aggregate exception, then you've probably worked with the task parallel library before, because an aggregate exception is what the TPL uses to wrap up exceptions that are happening from multiple operations that are executing in parallel. Wraps up all the different exceptions, puts them into a single aggregate exception, and then you can inspect that to see the different things that went wrong. But the TPL behaves a little bit differently with the await operator in place, and there still is an aggregate exception behind the scenes with all of the exceptions that have happened, but the runtime is only going to throw the first exception from that list of exceptions. That's what you're going to see. That's what you could try to put inside of a try-catch. And so your try-catch can be set up pretty normally. You don't have to worry about aggregate exception. You can just try to catch the exceptions that you expect these async operations to throw. The one you'll see is whichever one came out first. Finally, I want to touch on unit testing a controller action. Now, the index action that we have in the home controller is an async method, and it's not very testable at this point because it has two hard-coded dependencies on web services. Ideally, we'd be unit testing the index action and it wouldn't talk to those web services. We'd be using dependency injection and fakes or mocks to make sure that it doesn't. But I'll leave those discussions for other Pluralsight courses that cover those topics in detail. And I just want to use this simple example for a demonstration purpose, which is, because the index action is now async, I cannot write this simple test and just expect that I'll get a view result back from calling the index action and be able to dig the model out of that to check if it's not null. Because index no longer returns a view result, it returns a task of action result or a task of view result because it's an asynchronous method now. The easiest solution to this problem is to go in and, if you have a test runner that supports it, also make your unit test method an async method. So literally adding the async keyword here, changing this to a task so we give it something back to know when everything is complete. And then what I can do is I can await the controller.index action, and I can cast that result to a view result. That will allow me to get to the model. Now, again, it is important that you have a test runner that supports this. So this is affectionately what we call MS Test, the testing framework that's built into Visual Studio. It supports async unit test. Also, xunit.net, which is a very popular open source unit testing framework written by Brad Wilson and Jim Newkirk, and Brad happens to work on the MVC team. It also supports async test methods. Those are probably the directions that you want to go if you're going to have async controller actions, because it makes testing those actions much easier because you can use async await keywords, which clean up the code considerably. In this module, we looked at async controller actions and saw how the C#5 compiler and the async await operators make a huge improvement in how we write asynchronous code. It's easy now, and the code is readable because it still has a synchronous flow, even though threads might be jumping in and out during runtime. I showed you how structuring a controller action and where you place the await keyword, that's significant if you want to have parallel operations running. And we also implemented timeout errors and unit test. Remember, the entire goal was to keep server threads busy to build a more scalable web application, and I demonstrated how async actions can do that job for us.